Time to get to 1.6. We're almost done with chapter 1. I want to do these notes for you from scratch because this is a little bit more complex. So we're going to go through it together. So the first thing we're going to learn is that a curve is a continuous set of points. It's not a certain shape. It is just a continuous set of points. Most of you would think of a curve and you would think of something like that. But keep in mind, that is actually a curve also. That is a curve. And that is a curve. Okay, those are all curves. Something that goes like this, where it has a point missing, okay, that's not a curve because it has a point missing in the middle. Continuous, meaning if I set my pencil down, I can draw the whole shape without picking up my pencil. Okay, so that's just a curve, basic. Now we're going to talk about closed curves. Those are curves that begin and end at the same point. So two that are the most popular would be that curve and that curve. Again, when you set your pencil down, you can draw the shape and you do not pick your pencil up. And for closed, you come back to your starting point. Now, are these the only two closed curves? Absolutely not. Do they have to look like a certain shape? Absolutely not. We can have a closed curve that looks something like that. Fact is, I started in one spot, I drew a curve, and then I came back to my original spot without picking up my pencil. Okay? So this is one type of curve. Closed and simple have nothing to do with each other. Absolutely nothing. It can be closed and simple, it can be closed and not simple. It can be a curve and simple or closed and simple. So they really don't have anything to do with each other. You have to test them separately. Simple curve means it does not cross over itself. So something that goes like that, that would be simple. It does not cross over itself. Something that goes like that, that is also simple. I closed it. That is also simple. Okay, so if it crosses over itself like this, yeah, that is not a simple curve. Okay, simple, does not cross over. So when you get a curve, you need to ask yourself the three questions. Number one, you need to make sure it's a curve. Is it a curve? Yes or no? Number two, is it closed? Yes or no? And number three, is it simple? Yes or no? Questions have nothing to do with each other, so take each question separately. Okay, for the next part, we're going to talk about circles. In the last section, we talked about dividing a line into three disjoint sets and a plane into three disjoint sets. Here, we're going to talk about dividing a circle into three disjoint sets. So we have the set of interior points of the circle, right? That is everything inside of our line. That's the interior of a circle. Everybody remembers that. We have our exterior points, which is everything outside of the circle, but in our plane, right? And then we actually have the circle itself. So the points that make up the circle become our third disjoint set. So a point can only be in one spot. It can be inside the circle, outside the circle, or on the circle. But it cannot be in more than one of those places because they are disjoint sets. So when I'm actually saying the name of a circle, so this one is circle, that's your symbol for circle, circle K. The point I use to name my circle is actually not a point on the circle. Kind of weird, but that's just the way circles are. They can be a little bit weird. All right, so before we go farther, let's even get the definition of a circle. So definition of a circle is a circle is a set of points a given distance from a given point. Okay, and the given point is a center. So I have the center of my circle, and when I create it, basically what I'm doing is taking the same distance from that center point, and I'm linking them all together. Now don't judge my drawing, yours isn't much better. Okay, but that's the idea, that the distance from this center to the point on the circle is the same no matter where you go. That's how we create a circle, hence all radii are the same. So we do name a circle using its center point. So if I have my circle here, the center of my circle will be the name. So this would be circle R. It's not a random point somewhere inside the circle. It is the center of the circle. You don't name it with anything but the center. Okay? So let's dive a little bit deeper. If we're talking about the area of a circle, which you guys already know how to find, we're actually talking about the points that it would include the points on the circle and the interiors. So it's going to include 2 out of 3 of those sets. So it's going to include the points on the circle, and then it's going to include everything inside the circle, and we call that a region. Now notice, you have to have something that's closed, right, beginning and ending in the same spot before you can have a region. If it's open, there's no way to create a region there. Okay? All right, now let's get on to polygons. So a polygon is actually a curve, but it's a simple closed curve, and the curve is made up of segments. So yeah, a triangle is a curve. It's a polygon because it's a curve made up of segments. Okay, segments are special types of curves. They go in a straight line, basically. All right, please try to get out of your head the normal shapes. Okay, triangle, kind of hard to do much with a triangle, but it is a 3-sided figure. Okay, quadrilateral, don't think of rectangle and square. Quadrilateral is simply any shape with 4 sides. So most of you, if I had said draw a quadrilateral, that's what you're going to draw. But understand, this is just as much a quadrilateral because it has 1, 2, 3, 4 sides. Okay, this pen is not working very well, so let me see if I can find another one. I'll just use pencil. So that means when we come to pentagon, you all are thinking in your heads, oh, I can draw like that house shape, and that's a pentagon. Well, you can. So this is what you're used to drawing for a pentagon, right? It's got 5 vertices and it's a house. Keep in mind, that could be a pentagon. And you go, what? Has 5 segments. That's a pentagon. Okay? Hexagon has 6. So again, you're going to try to draw something that you know from real life or from out in the world. All that means is we've got 6 segments going on. Oops. Okay, so please try not to just do the quote usual shape. Understand, when we get down to 7, it starts getting a little bit harder to draw a regular shape. It's almost easier to draw an irregular shape. So we can go 1, 2, 3, 4, 5, 6, 7. That's a heptagon. Doesn't look like anything I've ever seen in my life. In real life, it's still a heptagon. It has 7 sides. Okay, octagon. Everybody's drawing a stop sign right as I speak. I know it, because that's what we're used to. Geometry is about getting out of the box that you're used to. Now, am I cheating? You betcha. I've drawn this 6 times. But I'm still knowing that 1, 2, 3, 4, 5, 6, 7, 8. That's still an octagon. It doesn't look a darn thing like a stop sign, but it's still an octagon. It has 8 sides. So what you have to memorize, and some of these you already know very well, but you have to know 3 through 10. Okay, so if I ask you what's a 9-sided figure, you better know that's a nonagon. If I ask you what is a 10-sided figure, you better know it's a decagon. Okay, That's your responsibility. You should be able to draw all of those as well. Again, when you get up into the higher ones, it's better to put your points down than connect them. Okay? All right. So that's all on the different sides of a polygon. Now let's get to some talks about it. Equilateral polygons. Okay, I think we know what equi means, right? Equi means equal. That's kind of simple. We all know that one. The question is, do we know lateral? Okay, and lateral means like line, which is where we get our side. So equilateral is going to be equal sides. Now, what do we know that has equal sides? Well, we know that a square has equal sides, right? That's the one that we're all most common, is the most common one. We're all familiar with that. But there is one other shape that also has same sides, and that is actually a rhombus. I don't have my little cheat sheet, so a rhombus has 4 equal sides. Okay? If we go down here, we're going to go to equiangular. Well, kind of like lateral was line or side. Angular is angle. So here we're talking about equal angles. Okay, well, there's a few of those. We can have an equiangular, it doesn't look like it, I know, get over it, triangle, right? Each angle is 60 degrees. We can have an equiangular quadrilateral, also known as a rectangle. And there's other shapes. All of them can be equiangular. Now, here's the one you have to know. Okay, circle this, star it. Regular polygon. No, it doesn't mean it's just a regular old shape. No, it means it's equilateral and equiangular. Okay, so that means a square would be regular because all of its sides are the same length and all of its angles are the same measure. So a square is equilateral and equiangular. So it is a regular polygon. You can also have, that's not going to look right because it's not drawn right, but let's pretend that all 3 sides of that triangle are the same and all 3 angles of that triangle are equal. So that is, again, a regular triangle. All sides are the same length, all angles are the same measure. Okay? All right, last thing for 1.6 on this page is going to be diagonal of a polygon. You know what a diagonal is in terms of you know how to draw it. Okay, but you don't have a definition of it. So I'm going to use basically a pentagon here. And I'm going to make my house shape that you guys love because it's familiar, it's comfortable, but we're going to turn it on its side. Okay? So I'm going to have my little vertices here at my corners where my 2 segments meet. All right, diagonal of a polygon, it is a segment that connects 2 non-consecutive, there's your key, non-consecutive, not next to each other, okay, non-consecutive vertices. So that means if I start at this vertex, I cannot go to that one, I cannot go to that one. I can go here, or I can go here. Okay? If I start at this vertex, nope, no, I can go to here or to here. Okay? And you work your way around the shape. If I start at this one, I can't go here or there. That goes back to here, but then there's another one that goes there. And then again, you work your way around. So I'm missing one, right? Everybody say I'm missing one. Where is it? Let's see, that goes to there and there. Am I missing one? That goes to there and there. Oh, look, I have them all. So you need to check every vertex when you're trying to see about diagonals, okay? That's something you need to check. All right, last page in this section is all about circles. Circles, they're beautiful. I'm gonna have to get my template for this, so hang on. Okay, I'm back, and I drew 6 circles while I was gone. So you have all hopefully seen a little template like this. Might be a good idea to grab one. It's called a geometry template. I think you can get them on Amazon for like $3, but it has a bunch of different shapes. Just makes life easier when we're drawing shapes. Okay, I'm a double dip here and put some definitions down here while we're doing this. Okay, so 10A, more cool stuff about circles. A chord. Chord is a segment whose endpoints are on the circle and all other points are in the interior of the circle. Okay, that's important because if I don't say where the points are between the endpoints, it can get wonky. Okay, so a chord has its endpoints on the circle. Okay, so endpoints on the circle, and all of the other points are in the interior. So we're going to connect our endpoints, and this is a chord. You might have seen that one before. That's one of the more common ones. Okay, I'm going to do B next. So B says a secant, it's not a secant, a secant is a segment, ray, or line that intersects the circle twice and has points outside the circle. Okay, well, if it's going to intersect it twice, then I've got 1, 2. So it said that it could be a segment, could be a ray, or it could be a line. I'm going to draw a line because I think that's a little easier when you are learning what a secant is, to see some of the points are outside, some of the points are inside. Now that secant could touch way up here, it could touch way over here, it could touch here, anywhere along the circle. Okay? Tangent. Tangent is something you've probably seen, but you may not have understood or have the definition. So a tangent is a segment, ray, or line, and it intersects the circle once and has no interior points on the circle. Okay? I always think of tangent touches the circle. That's just how I'm able to do it. So if that is my point right there, my tangent is just going to touch the circle in that one point, and every other point of that line, segment, or ray is going to be outside of my circle. So this is my tangent that touches my circle. Okay? So these are 3 musts. Those are ones you don't know this much, but you must learn them. Okay, so draw pictures, use flashcards, whatever you have to do to get that. All right, bottom 3. I'm going to have to fold this a little bit. You really kind of already know these. I'm just going to read the definition. So a radius, a segment whose endpoints are the center of the circle and a point on the circle. Okay, so you know what a radius is. We just gave it a little definition, but you know exactly how to draw it. You've drawn a million of them, and you've used a million of them in area formulas and all kinds of stuff. Okay, the next one, diameter. Okay, keep in mind, a diameter is a chord. It is a special chord. A special chord that goes through the center of the circle. So again, chord, endpoints are on the circle and all points are in the interior. Diameter is a chord because all of its points are in the interior, but it goes through the center of the circle. Okay, chord. And the last one that you have is arc. An arc is a piece of the circle, so it is a subset of the circle, and it is actually part of the circle. So it doesn't go through it in any way. It actually is the points that are on the circle. So this is an arc. Okay, so there are your 6 things about your circle. Some of which you knew, some of which you probably didn't. All right, last thing real quick, we're going to do circumference, which is basically the perimeter of a circle. Circumference equals 2 pi r. Another way to write this is circumference is also 2 pi d, pi times diameter, because the radius, when you multiply by 2, is the diameter. Everybody remember that? So you need to memorize that, and you need to memorize area of a circle is pi r squared. Okay, so let's just do a quick or not memorizing, let's do a quick area and circumference of a circle. So here's my circle, and you're going to be given something. I'm going to give you that the radius is 3 inches, and I want to find circumference and area. So C equals pi 2 pi r, because we're doing circumference, and area equals pi r squared. Okay, so C equals 2 pi radius. Well, 2 times 3 is what? 6. So 6 pi inches. Stop there. This is what we call our exact answer. As soon as you pop that pi into a calculator, you are not exact anymore, you are estimating. So if it says exact answer, pi better be in there. Okay? Same thing for area. Area equals pi radius squared. What is 3 squared? That's 9. 9 pi inches squared. That is your exact area. Do not go any farther. You also must have the units squared for an area and the units in the first power for your circumference. Okay? That was a little long, but you got through 1.6. I'll see you at 1.7.